Hi to everyone. Lessons from www.iasgeneralstudies.com. In this geography class, today we are going to study about the composition and the structure of atmosphere. What is atmosphere? The atmosphere is nothing but a thick gaseous envelope attached by the gravitational force to the Earth's surface, and it filters the incoming radiation. So if you have the Earth's surface like this, okay, so this is the Earth, and the atmosphere will be some gaseous layer which is attached towards the Earth surface by the gravitational force, and it filters the incoming solar radiation. The height of the atmosphere is from 16 to 29,000 kilometer, and the very important point here is 97% effective atmosphere is up to 29 kilometer. So make a note, this may be our prelim question. So the 97% of the effective atmosphere present up to 29 kilometers only, even though the extent of the atmosphere is several thousand kilometer. And atmosphere mainly composed of gases, vapors and particulates. We'll study one after the other. Gases. What are the gases? Nitrogen. It present 78% and the oxygen present 21%, and the remaining 1% is represented by the argon, carbon dioxide, neon, helium, ozone, hydrogen, etc. all in the smaller proportion. So the important point to note here is the nitrogen, which is 78%. Clear? Oxygen. Oxygen is important for the living organism, which we know very well, and it helps in the combustion. Regarding the nitrogen, it acts as a diluent and is generally chemically inactive. So nitrogen is chemically inactive. Now coming to the water vapor presents 0 to 5% in the volume content, that is 0 to 5% present as a volume content, and it depends on the temperature. It decreases from the equator poleward in response to decreasing temperature towards the pole. Clear? So the water vapor decreases from the equator to the pole because there is a decrease in the temperature towards the pole, and the content decreases upward also. So when we move from the Earth surface to the higher altitude, the water vapor content decreases, and more than 90% found up to 5 kilometers only. Even though the atmosphere is extend to several thousand kilometers, more than 90% of the water vapor found up to 5 kilometers only. Now, the water vapor is transparent for the incoming short wave solar radiation, but less transparent for outgoing short wave terrestrial radiation. Now regarding the particulate matter, solid particles in atmosphere, dust particle, salt particle, pollen, smoke and soot, volcanic ashes, etc., and they help in scattering of the solar radiation. So this may be our question in the exam. So what is the cause for the scattering of the solar radiation in the atmosphere? It is nothing but the particulate matter. Fine. Now we are going to study about the structure of atmosphere. The height up to 800 km is the most important. 50% lie below 5.6 km and 97% confined to the height of 29 km. So we are going to study about the atmosphere, and the height up to 800 km is most important, but 50% of the atmosphere, entire atmosphere, lies below 5.6 km and the 97% confined to the height of 29 km. Now the upper limit is considered to be some 10,000 km. Okay, there are 4 layers in the atmosphere. The first layer is troposphere, then we have stratosphere, then we have mesosphere, and then we have thermosphere. So we'll see all the 4 layers in the diagram now. Here we have a Earth, and we just now saw there are 4 layers. So just we'll put the layer. The first layer is nothing but the troposphere. So just memorize now itself. Troposphere, then stratosphere. Okay, the first layer is the troposphere, then we have stratosphere. What is the next layer? Mesosphere, then thermosphere. So we have meso, then thermosphere. So the order is very important. Okay, so troposphere, stratosphere, mesosphere and thermosphere. Okay, fine. Now let us study about the troposphere. It is the lowermost layer. All the weather phenomena occurs here. So this is the lowermost layer and all the weather phenomena occurs here. Fine. The temperature decreases with increase in height at the rate of 6.5 degree per 1000 meter. Very important point. When you move up, okay, the temperature decreases at the rate of 6.5 degree centigrade per 1000 meter or 1 kilometer. It's very important point. This may be our prelim question. So the decrease in the temperature when we move up is at the rate of 6.5 degree centigrade per 1000 meter. 1000 meter nothing but 1 kilometer. Okay, and this rate of decrease is called as the normal lapse rate. So this is nothing but the normal lapse rate. So if they ask you what is normal lapse rate, you should be able to tell that when the height is increased, the temperature decreases and the rate of decrease is 6.5 degrees centigrade per 1000 meter. Is it clear? Fine. Now the height of the troposphere changes from equator towards the pole, that is decreases, and from one season to another it increases during the summer while decreases during the winter. Is it clear? The height of the troposphere changes from equator towards the pole, that is it decreases. So if the height of the troposphere changes from the equator towards the pole, that is it will decrease. So I'll show that in the diagram now. We have the earth surface, okay, and I will put a different diagram now for better understanding. So we have a earth like this, okay, and let me take this as the equator now. Let this be our equator and let this be our pole. So atmosphere is like this present here. Okay, so if you see the stratosphere, what is the concept we saw? It decreases from equator towards pole, it decreases. So suppose this is the layer of the troposphere, it will be like this actually, okay, like this, but it decreases towards the pole. So it means when you come to the pole, the thickness decreases. Do you see the difference in the thickness? So the thickness is so much in the equator and the thickness is only this much in the pole. Okay, for a change I put this type of diagram. Usually earth is like this and we put a equator like this, isn't it? And for a change I put the diagram like this to represent the decrease in the length towards the pole. So the height of the troposphere changes from equator toward the pole, that is it decreases, and from one season to another it increases during summer while decreases during the winter. And the average height is 16 km over the equator and 6 km over the poles. So again this average height is 16 km around in the equator and it is just 6 km in the pole. So I think you are understanding better because of the diagram. Now the upper limit of the troposphere is tropopause, which is 1.5 km thick. So here we have tropopause, okay, the upper layer, this is the tropopause which is 1.5 km thick. So this is tropopause and this is troposphere. Okay, fine. And the temperature at the top of the tropopause is the lowest over the equator, that is minus 70 degree, and is relatively higher over the poles. So it is minus 70 degree is the temperature at this point, okay, which is relatively high over the poles. Is it clear? So we have learned about the troposphere in detail, and in the next video let us start about the stratosphere. Okay, fine.